December 7, 1941. The Japanese attack on Pearl Harbor plunges the United States into the Second World War. Within hours, American submarines are ordered to take the fight to the enemy. These boats, the steel sharks of the Pacific, carry with them weapons that would determine the fate of entire campaigns. Torpedoes, the submarine's primary armament, the weapon that could sink battleships, cripple carriers, and strangle an empire's supply lines. But as American submariners would soon discover, not all torpedoes were created equal. And in the desperate early years of the Pacific War, the United States Navy faced a crisis that would cost lives, waste opportunities, and nearly lose the submarine war before it truly began. This is the story of two torpedoes, the American Mark X, a weapon designed in the 1920s. Simple, reliable, some would say obsolete, and the Japanese Type 95, a technological marvel, fast, powerful, deadly, by all accounts the superior weapon. Yet when American submariners captured Japanese submarines and examined their torpedoes, when they test-fired these supposedly superior weapons, when they had the chance to choose between their own Mark X and the enemy's Type 95, they made a choice that shocked many observers. They chose the Mark X, the simple torpedo, the old torpedo, the supposedly inferior weapon. Why? To understand this decision, we must travel back to the beginning, to the development of these weapons, to the theories that shaped them, to the desperate battles that tested them, and to the men who bet their lives on them every time they went to sea. Our story begins not in the Pacific, but in the quiet offices of the Naval Torpedo Station in Newport, Rhode Island. The year is 1923. The Great War has been over for 5 years, but its lessons still echo through the halls of military planning offices worldwide. The submarine, once considered a questionable weapon of dubious value, has proven itself as a formidable tool of naval warfare. German U-boats nearly starved Britain into submission, and now every major naval power is racing to develop better submarines and better weapons for those submarines. The United States Navy faces a challenge. Their existing submarine torpedoes, developed before and during the Great War, are showing their age. They need a new weapon, something modern, something that can take advantage of the latest technological advances. But they also need reliability. They need something that works. The result is the Mark X torpedo. At first glance, it's not impressive. 18 feet long, weighing about 2,000 pounds, powered by steam generated by burning alcohol and compressed air. It can reach speeds of up to 36 knots and travel about 3,000 yards. Its warhead contains just over 500 pounds of TNT. By the standards of 1923, it's adequate. By the standards of 1941, when war breaks out, it's obsolete. Newer torpedoes, like the Mark XIV, can travel farther, run deeper, and carry larger warheads. The Mark X is relegated to older submarines, the S-boats, small coastal defense vessels that most naval planners consider second-line units, but the Mark X has something going for it, something that will prove invaluable in the years to come. It's simple, beautifully, wonderfully simple. Its steam propulsion system is straightforward. Its depth control mechanism is basic but reliable. Its contact exploder, the device that detonates the warhead when it hits a target, is uncomplicated. If something goes wrong, a submariner with basic training can often fix it. And most importantly, when a Mark X leaves a torpedo tube, it runs straight, it runs true, and when it hits something, it explodes. Now, let's turn our attention to Japan. In the 1920s and 30s, the Imperial Japanese Navy is obsessed with a single concept: decisive battle. They believe that any war with the United States will be decided in one massive fleet engagement, a modern Tsushima, where Japanese skill and superior weapons will overcome American numerical superiority. To achieve this, they need weapons that can strike first, strike hard, and strike from beyond the range of American guns. They invest heavily in torpedo development. The result is a family of weapons that will become legendary. The Type 93 for surface ships, known to the Allies as the Long Lance, arguably the finest naval torpedo of the Second World War. And for submarines, the Type 95. The Type 95 represents the cutting edge of torpedo technology. It's longer than the Mark 10, 23 feet, and heavier, nearly 3,000 pounds. But what makes it extraordinary is its propulsion system, pure oxygen. Instead of compressed air, which is only 21% oxygen, the Type 95 uses nearly pure oxygen to burn its fuel. This gives it tremendous performance, speeds up to 49 knots, range of over 5,000 yards. And because it burns more efficiently, it leaves almost no wake, making it nearly invisible on the surface. Its warhead is larger, carrying over 800 pounds of explosives. In theory, it's a submarine captain's dream. Fast enough to catch almost any target, powerful enough to break a battleship's back, stealthy enough to approach undetected. On paper, it's vastly superior to anything in the American arsenal, including the newer Mark 14, let alone the ancient Mark 10. But there is a problem, actually several problems that won't become apparent until these weapons are used in combat. Problems that stem from the fundamental difference in design philosophy between American and Japanese engineers. The Type 95 is complex. Its oxygen propulsion system requires careful handling. Pure oxygen is dangerous, extremely dangerous. Any contamination, any oil residue, any dirt in the system can cause a catastrophic explosion. Japanese submarine crews train extensively in handling these weapons. They follow elaborate procedures. They maintain their torpedoes with almost religious devotion. But even then, accidents happen. Torpedoes explode in their tubes. Submarines are lost. The Type 95 demands perfection from its operators, and in war, perfection is a luxury few can afford. December 7, 1941, Pearl Harbor. The Japanese strike force withdraws, leaving behind a scene of devastation. Battleship Row is a mass of burning, sinking steel. But the American aircraft carriers are at sea, untouched, and the submarine base, though damaged, is operational. Within hours, American submarines are heading out into the Pacific, their crews eager for revenge, their torpedo rooms loaded with the Navy's newest and supposedly best weapon, the Mark 14. The Mark 14 is meant to be America's answer to modern torpedo warfare. It's faster than the Mark 10, capable of 46 knots. It has greater range, over 4,000 yards. It runs deeper, beneath a ship's armored belt, where the hull is thinner. And it's equipped with 2 exploders, a contact exploder for direct hits, and a revolutionary magnetic exploder, the Mark 6, designed to detonate the torpedo as it passes beneath a ship's keel, breaking the vessel's back with a bubble of expanding gas. On paper, it's a war winner. In practice, it becomes a nightmare. The first American submarine to make contact with a Japanese ship is the USS Swordfish on December 16, 1941. Lieutenant Commander Chester Smith fires 3 Mark 14 torpedoes at a Japanese merchantman. He hears explosions. He believes he's scored hits. But after the war, Japanese records show the ship was undamaged. The torpedoes either missed or failed to explode. This becomes a pattern. American submarines make contact. They maneuver into position, often at great risk. They fire their expensive, carefully maintained Mark 14 torpedoes. They hear explosions, but when they raise their periscopes, they see their target still afloat, still moving, sometimes not even aware they've been attacked. The reports flood back to Pearl Harbor and to the submarine headquarters in Australia. Torpedoes are running too deep, passing beneath their targets. Exploders are failing, hitting ships squarely but not detonating. Magnetic exploders are triggering prematurely, detonating before reaching the target or not triggering at all. Some torpedoes are running in circles, threatening the submarines that fired them. The submariners are furious. They're risking their lives, penetrating defended harbors, closing to point-blank range only to have their weapons fail. They report the problems. They demand action. But the Bureau of Ordnance, the organization responsible for torpedo development, refuses to believe there's a problem. Their torpedoes have been tested, they insist. They work perfectly. The problem must be with the submarine crews. They're not maintaining the weapons properly. They're not aiming correctly. They're exaggerating their failures. This institutional denial will cost American submariners dearly. It will cost them opportunities. It will cost them ships. And it will cost them lives. Commander Howard Gilmore, commanding the USS Growler, fires 4 torpedoes at a Japanese freighter in February 1942. All 4 hit. All 4 fail to explode. The freighter escapes. Commander Dudley Morton, the legendary Mush Morton, fires 8 torpedoes at Japanese ships in January 1943. Only 1 explodes properly. He's so frustrated that he surfaces and sinks his target with his deck gun instead. Lieutenant Commander Lawson Ramage fires 9 torpedoes at a Japanese convoy in July 1942. 8 fail. He begins to wonder if he should just save his torpedoes and rely on his deck gun. The stories multiply. A submarine fires 6 torpedoes at a stationary anchored tanker from less than 1,000 yards. All 6 hit. None explode. Another submarine fires a full spread at a Japanese carrier. The torpedoes run under the target, their magnetic exploders failing to trigger. The carrier escapes. The submariners begin to develop their own solutions. They deactivate the magnetic exploders, relying only on contact detonation. They adjust their depth settings, trying to compensate for torpedoes that run too deep. They use more torpedoes per target, trying to overwhelm the weapon's unreliability with sheer numbers. But these are Band-Aids on a wound that needs surgery. Now here's where the S-boats enter our story. The older submarines, the ones armed with the Mark X torpedoes, the boats that were supposed to be second-line units, relegated to coastal defense, while the fleet boats with their Mark XIVs carried the war to Japan. But the S-boats don't report the same problems. Oh, they have their issues. The S-boats themselves are older, slower, less capable than the fleet boats. They can't dive as deep. They can't stay submerged as long. Their crews are cramped. Their range is limited. But their torpedoes work. The Mark X torpedoes, simple and obsolete, do exactly what they're supposed to do. They run straight. They run at the right depth. And when they hit something, they explode. Commander James Coe, commanding the S-39, reports successful attacks. Commander Nicholas Lucker, on the S-42, sinks enemy ships. The S-boat skippers aren't performing miracles. They're not the most aggressive commanders. Their boats aren't the fastest or most modern. But they're getting results because their weapons are reliable. This doesn't go unnoticed. As 1942 turns into 1943, as the torpedo crisis deepens, some submarine skippers begin to quietly wish they had the old Mark X's instead of the new Mark XIVs. At least the Mark X's work. But the Bureau of Ordnance remains in denial. They insist the Mark XIV is perfect. They blame the submariners. They resist every attempt to investigate the problems. It will take until mid-1943, nearly 2 years into the war, before the Navy finally conducts proper tests and discovers what the submariners have been reporting all along. The Mark XIV runs 10 feet too deep. The contact exploder often fails because it's too fragile, deforming on impact instead of triggering the detonation. The magnetic exploder is unreliable because it's affected by the Earth's magnetic field, which varies depending on location. The fixes, when they finally come, are embarrassingly simple. Adjust the depth setting, strengthen the firing pin on the contact exploder, deactivate the magnetic exploder entirely. By late 1943, the Mark XIV is finally becoming a reliable weapon. But 2 years have been lost. Hundreds of opportunities have been wasted, and American submariners have lost confidence in their weapons, confidence that will never fully return. Meanwhile, what about those captured Japanese torpedoes? As the war progresses, American forces occasionally capture intact Japanese submarines or recover Japanese torpedoes from sunken vessels. These weapons are sent back to the United States for analysis. Engineers examine them, test them, compare them to American designs, and they're impressed. The Type 95 is indeed a technological marvel. Its oxygen propulsion system is ingenious. Its performance specifications are outstanding. On paper, it's superior to any American torpedo, Mark 10 or Mark 14. But the American engineers also noticed something else. The Type 95 is complex, very complex. It requires specialized maintenance, specialized handling procedures, specialized training. The oxygen system is dangerous, requiring elaborate safety precautions. The torpedo's guidance system, while effective, is delicate and prone to malfunction if not properly maintained. Some American submariners are given the opportunity to use captured Type 95s in combat. This happens occasionally in the later stages of the war, when submarines are operating in areas where resupply is difficult and any working torpedo is valuable. The results are mixed. Yes, the Type 95 performs well when everything goes right. It's fast, it's powerful, it's stealthy. But everything has to go right. The torpedo has to be perfectly maintained. The oxygen system has to be completely clean. The crew has to follow every procedure exactly, and even then, there's an element of risk. The oxygen system can explode if mishandled. The complex guidance system can fail. For American submariners, used to the straightforward Mark 10 or even the now fixed Mark 14, the Type 95 represents a step backwards in terms of operational reliability. Sure, it's faster. Sure, it's more powerful. But is it worth the added complexity? Is it worth the danger? Is it worth the maintenance headaches? For most American submariners, the answer is no. They prefer weapons they can trust, weapons that work even when conditions aren't perfect, weapons that don't require a team of specialists to maintain, weapons that won't explode in the torpedo room if someone makes a small mistake. This preference isn't about stubbornness or pride. It's about survival. A submarine is an incredibly dangerous place to begin with. You're in a steel tube hundreds of feet underwater, surrounded by enemies, with no escape if something goes wrong. The last thing you want is a weapon that adds to that danger. A weapon that might work brilliantly 95% of the time, but that 5% of the time might destroy your boat and everyone in it. The Mark 10, for all its obsolescence, offers something the Type 95 doesn't: peace of mind. When a submariner loads a Mark 10 into a torpedo tube, he knows it will probably work. It might not be the fastest torpedo, it might not have the longest range, but it's reliable, and in submarine warfare, reliability often matters more than performance. There's another factor at play here. The American and Japanese navies have fundamentally different approaches to warfare. The Japanese Navy emphasizes quality over quantity. They build fewer ships, but each ship is excellent. They train fewer pilots, but each pilot is highly skilled. They develop fewer weapons, but each weapon pushes the boundaries of technology. This works well when you have time, resources, and trained personnel. But war has a way of degrading all three. The American approach is different, not because Americans are less capable engineers or less skilled warriors, but because American industry and American military doctrine emphasize different values: standardization, mass production, ease of maintenance, the ability to train new personnel quickly. These aren't exciting values. They don't make for impressive specifications on paper. But they win wars. The Mark 10 embodies these values. It's not the best torpedo in the world, but it can be mass-produced. It can be maintained by sailors with basic training. It can be stored for long periods without degrading. It can be used effectively by average submariners, not just elite crews. And it works consistently, mission after mission, month after month, even when conditions are less than ideal. The Type 95, for all its brilliance, requires the Japanese Navy's approach to work effectively. It needs highly trained crews, it needs careful maintenance, it needs time and resources that become increasingly scarce as the war progresses. For the Japanese, operating close to their bases with established supply chains and trained personnel, this is manageable. For Americans, operating thousands of miles from home, often with newly trained crews, relying on improvised supply systems, it's a nightmare. Let's talk about a specific example. The USS Nautilus, one of the large American submarines, captures several Type 95 torpedoes during a raid on a Japanese-held island in early 1944. The submarine's commander, recognizing that these are supposedly superior weapons, decides to test them in combat. His crew, experienced and well-trained, follows the captured Japanese manual's procedures as closely as possible. They clean the oxygen system meticulously. They check and recheck every connection. They load the torpedoes carefully. The Nautilus encounters a Japanese convoy. The commander fires 2 Type 95s. One runs hot, straight and normal, striking an enemy freighter and detonating properly. It's an impressive performance. The torpedo speed and power are evident. But the second torpedo runs erratically, circling and forcing the Nautilus to take evasive action. It's later determined that contamination in the oxygen system caused a pressure fluctuation, throwing off the torpedo's gyroscope. The commander fires his next salvo using standard American Mark 14s. By this point, late 1944, the Mark 14's problems have largely been solved. All 4 torpedoes run true. 3 hit their targets. All 3 explode. The commander's after-action report is diplomatic but clear. The Type 95 is impressive when it works, but he wouldn't want to rely on it. He trusts his own weapons more. This story is repeated across the Pacific. American submariners, given the choice between captured Japanese torpedoes and their own weapons, consistently choose their own. Not because they're better on paper, but because they're better where it counts. In combat, under pressure, in the hands of real sailors dealing with real situations. It's important to note that this isn't a criticism of Japanese engineering. The Type 95 represents brilliant design work. Japanese engineers created a weapon that pushed the boundaries of what was possible. In the hands of a perfectly trained crew operating under ideal conditions, the Type 95 is arguably superior to the Mark 10. But war doesn't provide ideal conditions, and few crews remain perfectly trained after months of combat operations. The Japanese Navy's other torpedo, the Type 93 Long Lance for surface ships, demonstrates this even more clearly. It's arguably the finest naval torpedo of World War II, fast, long-ranged, powerful, wakeless. In the night battles of 1942 and early 1943, Long Lance torpedoes devastate American and Allied forces. The battles of Savo Island, Cape Esperance, Tassafaronga all featured devastating Long Lance attacks that sink American cruisers and destroyers. But as the war progresses, as Japanese crews become less experienced, as maintenance standards slip due to supply shortages, as American forces develop countermeasures, the Long Lance becomes less effective. Not because the torpedo itself is worse, but because the conditions needed for it to excel are disappearing. By late 1944, American ships are actually hoping to face Long Lance attacks because they've learned how to defeat them, and because the Japanese ships firing them are often too inexperienced to use them effectively. The same principle applies to the Type 95. It's a weapon that requires everything to be perfect. And in war, nothing is ever perfect for long. Now, let's address the elephant in the room, the Mark 14. We've talked about how it was plagued with problems early in the war, how it cost American submariners countless opportunities, how the Bureau of Ordnance's denial nearly lost the submarine war, but we should also acknowledge that once those problems were fixed, the Mark 14 became a formidable weapon. By late 1943 and into 1944 and 1945, American submarines armed with Mark 14s are decimating Japanese shipping. So why are we focusing on the Mark 10? Because the Mark 10 story illustrates a crucial point about weapons design and military effectiveness. The Mark 10, despite being older, slower, and less powerful than both the Mark 14 and the Type 95, was more reliable than either of them for most of the war. It worked when the Mark 14 didn't. It was safer and easier to maintain than the Type 95, and reliability in warfare is often more valuable than raw performance. There's a parallel here to other weapon systems in World War II. Consider the Soviet T-34 tank. It wasn't the best armored tank. It wasn't the most powerful. German Panthers and Tigers could destroy it in a straight-up fight, but it was reliable. It was easy to produce. It was simple enough that conscript crews could operate it effectively, and it could keep fighting even when damaged, even in brutal Russian winter conditions that left more sophisticated German tanks frozen and useless. Or consider the American Force Sherman tank. British and American tankers complained about it constantly. It was under-armored. Its gun was less powerful than German weapons, but it was reliable. It didn't break down. It could be repaired quickly with basic tools. And there were thousands of them, while German Tigers, for all their superiority in one-on-one combat, were rare and constantly breaking down. The Mark 10 is the submarine equivalent. It's the weapon that shows up for work every day, does its job without complaint, and doesn't cause headaches for the people using it. That's not glamorous. It doesn't make for impressive statistics in reference books, but it wins wars. There's also a human element to this story. Submariners develop personal relationships with their weapons, not in a mystical sense, but in the sense that they learn to trust certain weapons and distrust others. A submariner who has fired 6 Mark 14 torpedoes at perfect targets and watched all 6 fail to explode will never fully trust that weapon again, even after it's fixed. The doubt is always there. The memory of failure lingers. Conversely, a submariner who has used Mark 10 torpedoes successfully, who has never had one malfunction dangerously, who has learned every quirk and characteristic through long use, develops confidence in that weapon. He knows how it behaves. He knows what it can and can't do. He trusts it, and that trust translates into more effective combat performance. When American submariners are offered Type 95s, they're being offered an unknown. Sure, the specifications are impressive. Sure, in tests the weapon performs well, but they don't know it. They haven't lived with it through months of patrols. They don't have the built-up familiarity that comes from repeated use, and they're aware of the weapon's reputation for being dangerous and temperamental. Why would they abandon a known, reliable weapon for an unknown, potentially dangerous one, even if the unknown weapon is theoretically superior? It's the same reason that experienced soldiers often prefer well-worn equipment to brand-new gear. The worn equipment has proven itself. They know how it will behave. New equipment might be better, or it might fail at a critical moment. Unless there's a compelling reason to change, experienced warriors stick with what they know works. Let's also consider the logistics and training aspects. By mid-1943, the American submarine force has established extensive infrastructure around their standard torpedoes. Training programs teach submariners how to maintain and use Mark 10s and Mark 14s. Supply chains are built around these weapons. Repair procedures are standardized. Technical manuals are widely distributed. Every tender, every submarine base, every support ship knows how to handle these weapons. Introducing Type 95s into this system would be a logistical nightmare. You'd need to train crews in completely different maintenance procedures. You'd need to establish new supply chains for oxygen and specialized parts. You'd need to develop new safety protocols. You'd need to write new technical manuals and translate Japanese documentation. And you'd need to do all of this while fighting a war, while keeping submarines at sea, while maintaining combat effectiveness. For what? For a weapon that, even at its best, is only marginally more effective than the fixed Mark 14, and that comes with significant additional risks and maintenance burdens? The cost-benefit analysis doesn't make sense. The American submarine force is already winning with their existing weapons. Why introduce chaos and risk for minimal gain? There is also a cultural element worth considering. American submariners, by 1943 and 1944, have developed a deep-seated confidence in themselves and their equipment. They've overcome the early disasters of the war. They've fought through the torpedo crisis. They've learned to operate effectively, even with flawed weapons. They've developed tactics and procedures that work. They're sinking Japanese ships at an incredible rate. This isn't the desperate, struggling submarine force of 1942 looking for any advantage they can get. This is a confident, effective force that knows it's winning. Submariners in this position don't want to experiment with enemy weapons. They don't want to introduce uncertainty. They want to keep doing what's working. They want to stick with their proven weapons and tactics. They want to maintain the momentum they've built. Introducing Type 95s would mean going back to square one in some respects, learning a new weapon, developing new tactics, accepting new risks. For submariners who have fought hard to reach their current level of effectiveness, that's an unappealing prospect. Now, it's worth noting that some American submariners did use captured Japanese equipment effectively. There are reports of submarines using captured Japanese radios, navigation equipment, and other gear. But these are typically items that complement existing American equipment rather than replacing it. And critically, they're items that don't pose a direct risk to the submarine's survival if they malfunction. A radio that breaks can be replaced with an American radio. Navigation equipment that fails can be backed up with other methods. But a torpedo that explodes in the tube or runs in a circle and hits your own submarine? That's catastrophic. The risk-reward calculation is entirely different. Submariners might be willing to experiment with non-critical captured equipment, but when it comes to weapons, they prefer what they know and trust. There's one more factor we should address: national pride. This is a subtle influence, but it's real. American submariners, like all military personnel, take pride in their equipment and their nation's technological capabilities. Using enemy weapons, even superior ones, feels like an admission that your own nation can't produce adequate equipment. It's a blow to morale. This isn't to say that American submariners wouldn't use Type 95s if they were genuinely, significantly better than American weapons. If the situation was desperate enough, if American torpedoes were completely ineffective, submariners would use whatever worked. But by the time captured Type 95s are available in any quantity, American torpedoes are working well enough. They're getting the job done. There's no desperate need to switch. Using enemy weapons is also potentially confusing from an identification standpoint. If a torpedo washes ashore or is recovered after an attack, you want it to be clearly identifiable as American or Japanese. Using enemy weapons muddies this distinction and can complicate intelligence assessments. Let's turn now to the broader strategic picture. American submarines are, by 1944, absolutely devastating Japanese maritime commerce. Japan is an island nation. Everything it needs to wage war, oil from the Dutch East Indies, rice from Southeast Asia, iron from China, must be transported by ship. And American submarines are sinking those ships faster than Japan can replace them. The statistics are staggering. American submarines will sink over 1,000 Japanese merchant ships during the war, totaling about 5 million tons of shipping. They'll also sink dozens of Japanese warships, including aircraft carriers, cruisers, and destroyers. They'll rescue downed pilots, conduct reconnaissance missions, land special forces teams, and generally make life miserable for the Japanese Navy. And they're doing all of this with Mark 10 and Mark 14 torpedoes. These weapons, for all their early problems, are proving adequate to the task. American submariners don't need Type 95s to win. They're already winning. The question isn't how to improve American torpedo performance. It's how to get more submarines to sea, how to train more crews, how to expand the campaign. This strategic reality makes the question of adopting Japanese torpedoes even less relevant. When you're winning decisively with your existing equipment, you don't change. You don't introduce new variables. You don't risk disrupting what's working. You maintain course and speed, as submariners would say. It's also worth considering what Japanese submariners might have thought if the situations were reversed. If Japanese submarines had captured American Mark 10s or Mark 14s, would they have adopted them? Almost certainly not, for many of the same reasons American submariners didn't adopt Type 95s. They'd be familiar with their own weapons, they'd have established procedures, they'd have pride in their own technology, and they'd be wary of introducing unknown elements into their operations. This mutual reluctance to adopt enemy weapons isn't unusual in military history. Soldiers generally prefer their own equipment, not because it's necessarily better, but because it's familiar, because it's supported by their logistics system, and because using enemy equipment raises practical and psychological complications. There are exceptions, of course. When one side's equipment is drastically superior, soldiers will use whatever works. Soviet soldiers in World War II eagerly used captured German weapons when they could get them, because German small arms were often better than Soviet equivalents. German tank crews sometimes used captured Soviet T-34s because they were more reliable than some German designs. But these are cases where there's a clear, significant advantage to using enemy equipment. The Type 95 versus Mark 10 comparison doesn't meet that threshold. Let's consider a hypothetical. Suppose the American Navy had decided, in mid-1943, to standardize on captured Type 95s for their submarines. What would have happened? Initially, there would have been chaos. Training programs would need to be rewritten. Supply chains would need to be established for oxygen and specialized parts. Maintenance procedures would need to be translated from Japanese manuals. Safety protocols would need to be developed for handling the dangerous oxygen system. During this transition period, American submarine effectiveness would have dropped significantly. Crews would be learning new weapons. Accidents would increase as sailors made mistakes with unfamiliar equipment. Some submarines would be sidelined for retraining and re-equipping. The entire submarine campaign would lose momentum. Eventually, assuming the Navy persevered, crews would learn the new weapons. Procedures would be established. The submarine force would regain effectiveness. But would it be more effective than before? Probably not significantly. The Type 95's advantages in speed and range would help in some situations, but American submarines already have effective weapons by this point. The improvement in combat effectiveness wouldn't justify the disruption and cost of the transition, and critically, there would be ongoing costs. The Type 95's complexity would mean more maintenance hours per torpedo. Its oxygen system would require specialized handling, slowing down torpedo loading operations. There would be more accidents, more lost submarines due to torpedo explosions. The overall effectiveness of the submarine force might actually decrease, despite using theoretically superior weapons. This is why military forces are generally conservative about changing equipment. It's not stubbornness or resistance to innovation. It's recognition that military effectiveness depends on much more than the raw specifications of individual weapons. It depends on training, logistics, procedures, and the intangible factor of troop confidence. Changing equipment disrupts all of these factors, and unless the new equipment is significantly better, the disruption costs more than the improvement gains. The Mark 10 versus Type 95 comparison also illustrates an important principle of military technology. The best weapon isn't necessarily the one with the best specifications. It's the one that best fits the operating environment, the logistics system, the training pipeline, and the tactical doctrine of the force using it. The Type 95 is optimized for the Japanese Navy's operating concepts: elite crews, careful maintenance, quality over quantity. The Mark 10 is optimized for American operating concepts: mass production, standardization, ease of use. Neither weapon is objectively better. They're different tools for different approaches to submarine warfare. The Mark 10 is better for the American approach. The Type 95 is better for the Japanese approach. Trying to use the Type 95 in the American system, or vice versa, is like trying to fit a square peg in a round hole. It might be possible with enough effort, but why bother when you have a round peg that fits perfectly? There's a broader lesson here about technology and warfare. Sophisticated high-performance weapons often require sophisticated high-performance support systems. Without those support systems, the weapons don't reach their potential. Sometimes, a simpler weapon that works within your existing support system is more effective than a sophisticated weapon that requires support you can't provide. This lesson has been relearned repeatedly throughout military history. The Germans in World War II built sophisticated tanks, planes, and other weapons that on paper were superior to Allied equipment. But these weapons were complex, difficult to maintain, and required highly trained crews. As the war progressed and Germany lost trained personnel, as supply chains broke down, as resources became scarce, these sophisticated weapons became less effective. Meanwhile, simpler Allied weapons, supported by robust logistics and operated by adequately trained crews, won the war. The same pattern appears in other conflicts. In Vietnam, American forces had sophisticated weapons and equipment, but often struggled against simpler Viet Cong and North Vietnamese weapons that were better suited to the environment and the type of warfare being waged. In Afghanistan, coalition forces with advanced technology faced insurgents using decades-old weapons that were simple, reliable, and perfectly adequate for guerrilla warfare. The Mark 10 embodies this principle. It's not glamorous, it's not impressive, but it's exactly what American submariners need: a simple, reliable weapon that works within their system, that matches their operating concepts, that doesn't require them to be anything other than competent, well-trained sailors. That's enough. That's all that's needed to win. As the war progresses into 1945, as American submarines continue their devastating campaign against Japanese shipping, the question of adopting Type 95s becomes even less relevant. By this point, Japan's merchant fleet is nearly destroyed. Japanese shipping is confined to coastal routes, too shallow for effective submarine operations. The war is clearly ending. This is not the time to introduce new weapons and new procedures. The few submarines still armed with Mark 10s continue to use them effectively until the end of the war. The S-boats, those obsolete vessels with their obsolete torpedoes, continue to patrol and sink enemy ships. They're not the stars of the submarine campaign. That honor goes to the fleet boats with their Mark 14s. But they contribute. They do their part. And their Mark 10 torpedoes work mission after mission, exactly as designed. When the war ends in August 1945, American submariners have sunk over 1,000 Japanese ships. They've strangled Japan's economy. They've isolated Japan's armies overseas. They've contributed decisively to the Allied victory. And they've done it with their own weapons, Mark 10s and Mark 14s. Not perfect weapons, but good enough weapons. Weapons that, despite early problems, got the job done. The story of why American submariners preferred their Mark 10 torpedoes over captured Japanese Type 95s is ultimately a story about reliability over performance, simplicity over sophistication, and the importance of matching weapons to the forces that use them. It's a story about how the best weapon isn't always the one with the most impressive specifications, but the one that works consistently in the hands of real operators under real conditions. The Type 95 was a brilliant piece of engineering, fast, powerful, stealthy, in many ways superior to the Mark 10, but it required perfection, perfect maintenance, perfect handling, perfect conditions, and war doesn't provide perfection. War provides chaos, stress, exhaustion, and improvisation. In that environment, simple and reliable beats sophisticated and temperamental every time. American submariners understood this instinctively. They'd lived through the nightmare of the early war torpedo failures. They'd learned the hard way that a weapon that works 60% of the time is worse than a weapon that works 90% of the time, even if the 60% weapon has better specifications. They'd developed trust in their Mark 10s, confidence built through countless patrols and engagements. They weren't going to abandon that trust for an unknown weapon, even a supposedly superior one. This decision, made not through formal policy, but through the collective judgment of hundreds of submarine commanders and their crews, proved correct. American submarines won the submarine war in the Pacific not with exotic captured Japanese weapons, but with their own reliable, trustworthy torpedoes. The Mark 10, obsolete and unimpressive though it might be, played its part in that victory. The legacy of this choice extends beyond World War II. It influenced post-war torpedo development, with American engineers emphasizing reliability and ease of maintenance alongside performance. It shaped doctrine and training, reinforcing the principle that weapons must fit the forces using them, not the other way around. And it provided a lesson that remains relevant today in an era where military technology is increasingly sophisticated and complex. That lesson is simple. The best weapon is the one your forces can use effectively, consistently, and confidently. Specifications matter less than reliability. Sophistication matters less than simplicity. And the newest, flashiest technology matters less than the boring, proven equipment that shows up for work every day and does its job without complaint. The American submariners who chose their Mark 10 torpedoes over captured Type 95s understood this. They chose reliability over performance, simplicity over sophistication, known over unknown. And in doing so, they made the right choice, a choice that helped win the war, a choice that serves as a reminder that in warfare, as in life, sometimes the old, simple, reliable option is better than the new, complex, temperamental one. The Mark 10 torpedo, derided as obsolete, mocked as simple, dismissed as inferior, proved its worth where it mattered most, in combat, under pressure, in the hands of American submariners, fighting for their lives and their country. It wasn't the best torpedo in the world, but it was good enough. And in war, good enough weapons used effectively beat superior weapons that don't work when you need them. That's why American submariners preferred their simple Mark 10 torpedoes over the deadly Japanese Type 95s. Not because they were stubborn, not because they were technologically backward, but because they understood what really matters in combat: reliability, consistency, trust. The Mark 10 provided those qualities. The Type 95, for all its impressive specifications, did not. And when your life depends on your weapons, when your mission depends on your equipment, you choose what works, every time.